Hello, everyone. My name is Brad Dispenza. I'm a Principal Security and Compliance Specialist with Amazon Web Services Public Sector. And today I'm going to talk to you a little bit about using lessons learned from the field to build for security. Quick overview of the agenda of what we're going to be covering today. I want to cover some common security mistakes that I see customers make in the field. What do you need to do to actually fix that mistake? And why do customers do it in the first place? I want to set the stage up front. There's going to be a lot of examples in this session in a very short amount of time, but it's recorded, so don't worry about trying to keep pace. If you feel like we're going too fast, don't worry, you can always scrub back. So with that, let's jump in and we're going to move quick. The first thing is guard duty. So the mistake I often see customers make is that they enable guard duty without enabling alerting. And what they don't know is, did I need to actually enable alerting? I thought I just had to turn on guard duty. So the fix is pretty simple. In this case, what you need to do to fix this is go into CloudWatch and create a CloudWatch event that correlates to the guard duty finding. At that point, the CloudWatch event can be used to trigger things like a Lambda function. It can use SNS topic notification or integrate with a number of other different capabilities. But the important part here is that you need to take the guard duty alert and do something with it. So an example, if you're not familiar with creating a CloudWatch event rule, is when you go into CloudWatch, this is an example of creating a rule, and you can see the process is pretty simple. In this case, all we need to do is select the event type. In this case, the event type is a guard duty finding, and then the target. So the target can be any of the supporting formats, but in this case, you can see I'm targeting a Lambda function. So the target is what's actually going to happen when you use the event notification. Sometimes when I talk to customers about this, they get stressed because that means that they need to write code for a Lambda function and they don't have developers. So what am I going to do? The answer is that oftentimes customers make their response functions more complicated than what they really need to be. This is an example of 9 lines of Python that will use a guard duty event notification, in this case, backdoor EC2 command and control activity communicating through DNS. And the response element here is whatever you would do from an API perspective when you receive that alert. So if you would isolate that EC2 instance by changing security groups or modify a network access control list or stop the instance, all of that is simply what you would do in that response field. And the key takeaway here is that you can see this is not complicated. Any customer can use these. And the good news is in the AWS samples library, there are a number of pre-made responses that already exist that you can use as reference items if you're going to start developing your own. So the next mistake I see customers make is they enable guard duty, but just in one region. And oftentimes customers didn't know that you need to enable guard duty in all regions. Guard duty, like many of AWS services, is a regional service, and that means that the service gets information from the region that it's in. But we only work in US East 1 or US West 2 or EU West 1. Why would I turn it on in other regions? The reason is that you want that information to come to you in regions that maybe you don't often use, but an adversary knows that you don't often use. So a good example. Sometimes we see when customers have an unfortunate security event where they have a situation where someone unauthorized is in their account, the adversary will look for where the majority of resources in their account exist, and then they'll go to use a region that has no resources, meaning it's often unused, unmonitored. When you don't enable guard duty in those regions, you don't get those notifications to know that an anomaly has occurred and that something unusual is taking place. So it's important, always enable guard duties. How do I fix that? Well, I've provided a simple shell script here to help customers enable guard duty in a region. What this is simply doing is going through all AWS regions, and then for each region, activating the guard duty detector for you. If that's too scary and you don't like writing shell scripts, good news, in CloudFormation, there's a stack set item also that will enable guard duty. So all you need to do is go into CloudFormation stack sets. You can choose a sample template, and here you can see there's the enable guard duty sample template. When you go to enable that, it will ask you what regions you want to enable the template. Simply enable all regions. Next is AWS KMS. So the mistake I see customers make is using service versus customer managed keys. And oftentimes the situation is that they didn't know they couldn't create a key policy on a service with a service managed key. So the fix and really why it's important. Customer managed keys allow customers to make changes to the key policy. It also allows for customers to do things like automatic rotation of keys annually if they want to. For AWS managed keys or AWS owned CMKs, we handle that rotation, but we don't allow the customer to manage the CMK policy. So why is that important? Well, in this case, you can see the key policy allows decrypt, describe, encrypt, and generate data key, and we can also specify a specific key. If you use a service managed key, you don't have the capability of saying a given principal, in this case CMK user, has these capabilities. It's available to all users in the account. So in plain English, what that means is if you want to restrict access to KMS key policy, you have to use a CMK, a customer managed key, and not a service managed key. So the next mistake I see customers make is key deletion in KMS. I didn't know a developer could delete keys. So the answer is that in Ken Beer, we trust. Ken Beer heads up the KMS service team. So in our documentation, we call out that destroying a customer managed key is a destructive and potentially dangerous operation. After a CMK is deleted, it is unrecoverable by AWS. So if you're not sure if you want to delete a key, instead we always advise customers to disable the CMK before actually deleting it. If you want to re-enable it later, you can always do that. And for key material that is generated from KMS, there is a default grace period of 7 days prior to a deletion occurring. But for customers that use imported key material, the delete operation is immediate, meaning if you're using imported KMS key material and you perform a delete operation on that key material, it is immediately taking place. So make sure that you don't allow this. And the way to fix this is by making sure that you have things like, in this case, an AWS config rule that looks for CMKs that were not scheduled for deletion. This will alert you that a CMK has been flagged for deletion, and it gives you that time to respond in the case that the developer thinks, oh, this key was used for this project, it's not used for prod. No, it was also used for prod. So we can enable this config rule to get that alert earlier so that we can go and respond and make sure that the impact is not wide-reaching. Or we can also use a more wide function, which would be a service control policy. In this case, you can see I'm using an SCP deny operation that would deny at the account level the scheduled key deletion and KMS key delete API. The downside to using an SCP is that all principals in the account, including the root principal, cannot perform these operations. So in order to actually authorize a key deletion in the account, you would have to go and remove this SCP. That said, for many of our customers, keys are used in perpetuity and perpetually, so key deletion tends to be more the exception rather than the rule. So if you don't want to run that risk, using an SCP deny statement is probably a better call. What about CloudTrail? So the example that I see for CloudTrail is that they forgot to make a trail and they didn't know that they needed to configure CloudTrails. So a good example there is, by default, CloudTrail is enabled in all AWS customer accounts, and it will record activity for 90 days. But what customers don't know is that if you want an ongoing record of events in your AWS account, you need to create a trail, and you need to enable that trail to deliver log files to an Amazon S3 bucket. CloudTrail allows customers to specify a multi-region trail, so everything aggregates to that single bucket, and customers can also specify a bucket that exists outside of the account that it's logging in. And a good example of why you would want to do that is to prevent an adversary from going and performing a delete operation on those log files inside of an account. So if you're worried about someone going and deleting the logs, just make sure that you designate a dedicated logging server or logging account inside of your organization, and then simply point to that log bucket location. If you're using AWS Control Tower or Landing Zone configurations, that is a default configuration for those. The fix for this one is fairly simple. So in the documentation, we point out how to do this, but effectively all you'll need to do is go and create the trail and specify the bucket that you need to configure. And then here you can see on screen, I'm also pointing out that we want to make sure that this is a multi-region trail by default, and also that we're making sure that we're pointing to the bucket that we intend to point to. The next mistake I see customers make that especially exists in those that are in regulated environments is they forgot to enable CloudTrail log file integrity. So the kind of response here is, I'm pretty sure they didn't modify the log files. So logs, especially CloudTrail logs, are critical in the event of investigations. And so what we want to do is make sure that there is a high confidence in the integrity of those log files. And here you can see on screen that I've indicated where we would go and enable that log file validation. And what that does behind the scenes is it allows us to create a fingerprint of the files as they're being persisted to the CloudWatch log storage, in this case S3. so that when we want to go and validate the logs, we can effectively perform a hash in the log function to make sure that the log files have not been modified, tampered, or altered in any way. The process for doing that is pretty simple. In this case, you can see a CLI snippet here where we're using the CloudTrail validate logs file function. And in the middle statement, you can see a more accurate example where we're calling out the start time for the range that we want to perform the analysis on, the end time where we want to sort of set our threshold, and then what specific trail ARN that we want to target. Below that, you'll see the output of that command would be validating the log files, and you'll see all the different log files coming through in that validation step. This just, again, helps us to identify any log file that may have been tampered, altered, or modified since its original persistence to the environment. Next is IAM. So the mistake I see customers make using IAM is using IAM users instead of roles. So the often response that I get here is, no, I think I revoked access when they separated. Oh, they were in that account too? Using identity federation is critical because it allows you to make sure that your onboarding and offboarding procedures follow your human resources policies, where when someone is added to the organization, likely they're tied into your central identity provider, and likely when the environment has an offboard for someone separating from the company, likely that is also deprovisioned at that time. The benefit to using identity federation is that it also makes sure that their access to resources that are hosted in AWS are also revoked at that same time without the user having to go and perform manual operations in the account. The fix in this case and why it's really important is using that identity federation, and there are a number of different capabilities that allow this. In this case, you can see that we have our centralized identity broker, and we're using that to federate the user into either the AWS console to get short-lived STS credentials or to allow access to the APIs via the CLI or SDK. There are a number of different federation options that AWS supports, so use the one that best aligns to your organization, but use some form of identity federation and don't use identity and access management users as much as possible. Even for machine-to-machine purposes, you can use federation for that purpose instead of relying on IAM users. So this is an example using AWS SSO for that identity federation. So again, if you're in a situation where you need to use an on-prem Active Directory and you want to use single sign-on but don't want to go through the hassle of configuring the SAML environment inside of AWS, AWS SSO makes that really simple. The blog post and documentation that I'm providing here gives you a walkthrough on how to integrate your identity provider with AWS SSO that will allow you to not only have access to AWS resources, but also single sign-on access to other resources like Office 365, Dropbox, or even Slack. The next mistake I see customers make in IAM is least privilege. So when you say that you deleted that prod server, this is a situation nobody wants to be in. So how do we make sure that people don't have more access than they really should? In this case, the fix is pretty simple. In Identity and Access Management, there's a tab called the Access Advisor. And the exact Access Advisor exists for users, groups, and roles, and it provides you with information about what that principal has been authorized to access and whether or not they're actually using it. So in this case, you can see that the user has been provisioned access to a number of services, but there might be gaps in when they're actually using it. This is a good opportunity to review that information and make sure that we have the appropriate permission for the roles so that if we're being overly permissive, we can see that the developers aren't in fact using these capabilities and roll them back. An example also is using the IAM Access Analyzer. And unlike Access Advisor, Access Analyzer looks at data over time. So Access Advisor, or rather Access Analyzer, can allow customers to get a better sense for how the different principals in their account are using the access that they have, and also give you a quick at-a-glance summary of the access level, whether or not it's write-only, read-only, or some combination in between. It also tells you when the policy was last updated, which gives you an idea of the staleness of the policy. This is something that customers can enable to better understand what principals have access to in their account and to reduce that time to discovery. The next mistake I see customers make is not alerting for root user. So the response here is something like, I too like to live dangerously. In this case, root is one of those things that AWS has documentation for that effectively there are only a very small subset of users that require root access at this point. Generally, customers should never be using the root access, and if they do, it should be an absolute exception. So the fix for this one is very simple. Inside of AWS's config environment, we can create either a custom config alert Or the document that I'm providing here comes from AWS Premium Support, and this uses a CloudWatch event rule, which can allow us to not only alert via a Lambda notification, but take that Lambda notification and integrate into SNS to start sending emails, or integrating with other providers like PagerDuty to start sending out pages, or creating things like a Slack bot to let the ops channel know that, hey, this user has just been used in this account. We don't use root. Do we want to go and investigate why that was being done? So the good news is here, a lot of the heavy lifting for this has already been done for you in this Premium Support Knowledge article. So again, if you want to know how to do this, take a look at this link. The next mistake I see customers make is not alerting for new IAM user creation. Remember, I told you not to use IAM users, but there are situations where customers, for legacy reasons, have to do that. And so the answer here is, so when did we hire Bob1, Bob2, and someone named Bob3? We want to make sure that we have a firm grasp on when we are enabling an individual to create users. And the fix in this case is to alert when a user is provisioned. Here again, we can see there's a Premium Support article that will walk customers through creating a CloudWatch SNS rule, very similar to the previous example for root user access. But in this case, it's looking specifically at the IAM create user and delete user operations. Or if you're taking the posture that we do not allow IAM users to be provisioned at all, we can use a more heavy-hitting approach, which would be an SCP deny statement. Again, remember, service control policies prevent all principals in the account, even the root user, from being able to perform an operation. In this case, the SCP would deny the deletion of users as well as the creation of IAM users. So if you're sure that you're going to be using identity federation and not IAM users, this is a really strong enforcement mechanism. So the next part here is under organizations. So the mistake I see customers make using organizations is not using a regional deny. So does anyone know why we launched a bunch of new instances in EU West 1 last month? So the problem here is that if you know that there's only a subset of AWS regions that you use, one strong policy would be to disable the use of other regions that you don't use. So how do you do that? Well, the fix in this one is, again, very simple because we have documentation to support it. Inside of the AWS organizations documentation, we list out how to do a regional deny. In this case, we can see the condition is for a string not equals EU Central 1 or EU West 1, and also that there is a subset of other commands that are required in order to make the environment work. And what that means in plain English is, in order to make your AWS account work, even if you're existing outside of US West 1, there are still a subset of services that require access to US East 1. So we want to make sure that those are allowed, but then at that point we can constrain access to only a specific region. For those in the US federal government, this is something that's really important if you want to make sure that you have US CONUS only operations. Allowing those service control policies to exist to only allow access to US regions, make sure that you're compliant with any of those regulations. And also going back to that example earlier where we had the guard duty event notification where we forgot to turn it on in every region, using this SCP deny will also prevent the use of regions that we're not constantly monitoring. The next mistake I see customers make is not using SCPs to deny security-sensitive changes. So the response here is, hey, over the weekend, I got a call and an alert that CloudTrail was disabled. Did anyone respond to that page? We don't want to have that situation. Where we know that there's a security binary that should never take place, simply enforce it in the service control policy. In this case, sensitive operations like disabling CloudTrail for the vast majority of AWS customers never happen. So instead, rely on creating an SCP deny statement that says you simply cannot perform these operations and don't rely on good intentions or after the fact event alerts. That doesn't mean that you still can't alert on the event failure. You can. In CloudWatch, you can create specific alerts that will tell you when a deny has gone through. But nonetheless, if we want to make sure that it's simply something that's not possible, again, even by the root principal in the account, create an SCP deny for those sensitive operations. Next, it's Amazon VPC. So the mistake I see customers make is they have a whole bunch of Launch Wizard security groups. No. Use Launch Wizard 432 to allow that access, I think. So the problem there is that Launch Wizard is not a very descriptive or helpful name for a security group. Instead, make sure that you're naming your security groups in a logical fashion so that you know what its purpose is at a glance. In this case, how do I identify all of those different Launch Wizard security groups inside of my environment? The answer here is I've provided a very simple snippet that you can run in the command line in your environment that will list all the Launch Wizard security groups for you, and then you can go and audit them and identify, are these Launch Wizards that we need, or can we properly rename them so that they're more helpful to our environment? Another better longer-term strategy is instead of relying on handmade security groups inside of your environment, instead consider the use of a service like AWS Firewall Manager, which allows customers that are using AWS organizations to centrally deploy security groups to all of the child accounts inside of their organization, rather than relying on manual processes to create them. The next mistake I see customers make is not using prefix lists. And wait, I didn't even know this existed. This is an incredibly powerful function that customers don't know about, and one that we just don't candidly speak enough about. Prefix lists allow you to create prefix lists that contain CIDR blocks that can be used in other security groups. So in plain English, what this means is rather than going through and creating a CIDR notation for your corporate IP space and then manually adding it to all of your security groups, simply create a prefix list that represents that corporate IP space. Then in your security group or other resources that rely on security groups, you can instead rely on the prefix list. But isn't that the same thing? No, it's not. Because when we modify the prefix list centrally, that propagates to all users in one shot. So that means in plain English, rather than having to maintain a number of disparate security groups and settings across the account, I can maintain one prefix list that's used by all of the child accounts in the organization. And now when we make a change centrally, it immediately impacts all users. Incredibly powerful, huge time saver. We wish more customers would do this. The next thing is public subnets. If I don't use a public subnet, how will I SSH in? The answer is you're doing it wrong. For most customers now, you don't need to actually use command and control access through services like SSH or protocols like RDP. Instead, we want customers to use AWS Sessions Manager. Sessions Manager allows customers remote direct access to their EC2 instances, and it prevents that user from having that exposure of that EC2 instance to the public internet. So no more audit reports for port 22 or other sensitive ports being exposed to the internet. Now you can use Sessions Manager, which requires no active port to be exposed in the security group. And for customers that are using remote desktop and want that interactive shell environment, you can also configure tunneling in Sessions Manager to allow you to forward that RDP session through the Sessions Manager tunnel. Again, huge win from a security perspective. You no longer have to have those sensitive listeners open to the public internet at all. The next mistake is exposed databases. We want the database to be accessible by everyone, but just not everyone. So in this case, the fix is pretty simple. We want you to go into config and create a config rule that identifies RDS instances that provide public access. Databases should almost never be publicly accessible. So this is one of those simple ones where if you have that, make sure you have an alert and you remediate that. The next is Amazon S3. The mistake is public Amazon S3 buckets. Finding data is hard, so we just let the internet do it for us. In this case, we want to make sure that we always deny public access for S3 buckets. At this point, there are very few reasons to have public access on S3 buckets, including for hosting static web content. You can actually, through CloudFront, create an origin that will allow you to feed directly from CloudFront without having to do a public bucket. There's still a lot of legacy existing blogs and articles that tell customers to use public access for S3. I want to tell you now with high confidence, you do not need to do that. You do not need public S3 access. The other thing is that customers may know that we provided a capability about a year or two ago, which will alert customers when public access occurs. This uses an underlying technology from the Automated Reasoning Group, which is an amazing set of technologies that you should go and watch the Automated Reasoning Group talk from last year's reInvent. But suffice to say, what that does is it uses a formal proof mathematical model in order to understand the policy of your environment to understand if the bucket is public. And what you see on the screen here is a listing of buckets that have a policy that maybe you didn't know caused them to become publicly exposed. If you don't want that risk at all, just simply deny public access to all buckets in the account. With that, we've covered a lot in a very short amount of time. And for customers that want to learn more about security with AWS, there is a number of security training capabilities that we offer through things like learning online, certifications, and the ability to identify yourself as a subject matter expert by using the AWS Certified Security Practitioner. So if you want to do a deeper dive on that, check out the AWS Security Learning Portal. And with that, I want to thank you. Oh, and one more thing, you can check in GitHub Secrets by using the Get Secrets capability, but they're going to pull me off stage now. So I hope everyone enjoyed this, and there's just a set of good checks for you to run. But please make sure that you fill out your session survey. And I want to thank everyone for the time this afternoon. Thank you.